I think the screen is visible. So today we will talk about assignment 8 for the course Newton particle physics. Okay. So let's start. Am I audible? Yes. Can anyone confirm me? Am I audible? Okay, fine. So let's start today's class. So today we will talk about the previous year question papers from the assignment 8 questions. So this is the first question from the previous year question paper. Assignment paper. So what is the first question? The first question is two firecrackers are fired from the ground at the same spot. The second one is fired 5 seconds after the first one. As seen from a high-speed train moving with constant velocity, the two events cannot be simultaneous. The two events are always simultaneous. The events can be simultaneous or separated by a time interval depending on the speed of the train. And the fourth option is the events will be seen as happening as two different positions. So this is the first question. So okay, as the people are coming still now, so I think we will wait for some time and after that we will start. So I am going to tell the first question again. The first question is two firecrackers are fired from the ground at the same spot. The second one is fired 5 seconds after the first one, as seen from a high-speed train moving with constant velocity. There are four options that the two events cannot be simultaneous. The two events are always simultaneous. The events can be simultaneous or separated by a time interval depending on the speed of the train. And the fourth one is the events will be seen as happening at two different positions. So let me first write something on that question. So this is nothing but a relativity question, right? So special theory of relativity. Sir already told you about this special theory of relativity. So we will just write the expressions for these right now. What are the expressions for special theory? If we are considering special theory of relativity in our condition, in our questions or problem, then what will be the modified expression? The modified expression will be like x prime x minus vt into gamma. So I am representing gamma means 1 minus root over 1 by root over v square minus So this is the x prime equals to x minus vt into gamma, then y prime will be y, z prime will be z, and t prime will be what? T minus v by c square into x into gamma. So these four are the nothing but the special theory of relativity expressions. Like if I use, there is a condition that v will be very very less than, or not exactly very very less than c, it will be very comparable to c. Okay, but in our classical mechanics course, if it is a classical mechanics, pure classical mechanics, then it will be like v is very very less than c. But for relativistic mechanics, then we can have a condition that v is comparable to c. So like let's say v is of the order of 0.1 c or 0.5 c, something like that, or 0.9 c also can be possible. So like that. So this is the expression for that relativity, with the help of relativistic equations. So these are the modified expressions for x prime, y prime, z prime and t prime. Now what is the question telling? So if I write here x prime, x into gamma, then what will be the value of delta x? Delta x means what? Let's say in one event will be at x1 and at t1 in the one frame, and another event will be at x2 position and at the time of t2 in this same frame. Okay, so now what we will calculate? We will calculate x1 prime and x2 prime, t1 prime and t2 prime. So what are these things? These things are like what will be the x2 prime, x1 and x2 x1 x2 and t1 t2 value in the other frame which is moving with respect to this frame, right? So what will be the value for that? Let's say like x1 prime is what? x1 prime is x1 minus v1 t1 into gamma, right? If it is moving with velocity v1, then x2 prime will be what? x2 prime is x2 minus, let's say v2 t2 into gamma. I am generalizing all these things. Let's say it is v1 and v2 in that different velocity, but obviously in one as these x1 and x2 are in a same frame and x prime and x1 prime and x2 prime are in the same frame, then v1 and v2 will be same, right? So let's say I am writing here v only, and what will be t1 prime and t2 prime? T1 prime will be t1 minus v by c square into x1 into gamma, and t2 prime will be t2 minus v by c square into x2 into gamma. So, and obviously that y1 prime will be y1, z1 prime will be z1. Then what will be the value of delta x prime? Delta x prime means like let's say x1 prime minus x2 prime or x2 prime minus x1 prime. We don't know which one is the like positive or negative or whatever. Then what will be the value of delta x prime? Delta x prime will be nothing but see here, yes, this one. Okay, so delta x prime will be delta x minus v into delta t into gamma, and what will be the delta t prime? Delta t minus v by c square into delta x into gamma, and obviously the rest of the things like delta y prime will be delta y and delta z prime will be delta z. Now in the question what they are asking, so I am just finalizing these two expressions so that you can understand. Delta x minus v into delta t into gamma, delta t prime will be delta t minus v by c square into delta x into gamma. So these two are the main expressions for our question, whatever it is showing. So what is the question? We can come in the question again. The two firecrackers are fired from the ground at the same spot. What is the meaning of this line? The meaning of this line, let's say at the ground means it is one one reference, right? Now what will be happening, like if the firecrackers are fired from the ground at the same spot means x1 and x2 will be same, x1 equals to x2. So what will be the value of delta x? Delta x will be 0, because at the same spot we are doing that. We are fired two firecrackers at the same spot, but the in different time. The second one is fired 5 seconds after the first one, so that means t2 is t1 plus 5. Okay, in this reference frame of reference. Now what will be the delta t for that? Delta t, let's say t1 minus t2, then it is like 5. So delta t will be 5 and delta x will be 0 from that question. As seen from a high speed train moving with constant velocity. Constant velocity means let's say we are talking about v, which is very much comparable to c. So that's why we are taking the relativistic conditions and all. Then what will happen in that prime reference system? So let's come to the expression again, and we have to take in mind that a delta x will be 0 and delta t will be 5. So yes, so we have already seen delta x will be 0 and delta t will be 5. Now we are putting the expressions here. So you can see that delta x prime will be what? Delta x is 0. Now it is 0 minus v into delta t, that means 5v into gamma, which is nothing but a non-zero value. That is the main thing, right? That means x2 prime is not equals to x1 prime. What is the meaning of it? The meaning of it is, even though the the crackers, whatever we are fired in that frame of reference, first frame of reference, it was at the same place. That means x1 and x2 was exactly same, but in the different frame it will not be same. That means x2 prime will not be equal to x1 prime. That is the main thing. Now coming to delta t prime. So what will be the delta t prime value? V by c square delta x into gamma. So here you can see our delta t was 5 and delta x was 0. So that means what? That means delta t prime will be 5 minus 0 into gamma. Let's say it is 5 gamma. So it is also non-zero. That is the main thing. So that means the t2 prime and t1 prime will not be equal. So whatever it was in that first frame, that means t1 and t2, these two were not equal, and there was a relation between t2 minus t1 will be 5. Similarly, there is a relation between t2 prime and t1 prime, and it is not that t2 prime is equal to t1 prime. Okay, so t2 prime is not equal to t1 prime, and from the first expression what we got that x2 prime is also not equal to x1 prime. Now coming to the four options. These two events cannot be simultaneous. The two events cannot be simultaneous means that simultaneous means at the same time. Okay, that means t2 prime and t1 prime will not be equal. The two events cannot be simultaneous. And also from our case we have calculated that t2 prime and t1 prime are not same. That means whatever the option is A, it is correct. Now the two events are always simultaneous. We have already seen that t1 prime is not equal to t2 prime, so that means this will not be the case. Now coming to the third option, the events can be simultaneous or separated by a time interval depending on the speed of the train. Okay, so what they are asking here, they are telling that, let's say, what was the expression for delta x prime expression was like minus 5 v gamma, and delta t prime is like 5 gamma. Now you can see that inside that gamma also there is v is there, right? 1 minus v square by c square. So v will be there, and from here also we can have a v. So depending on the velocity we can tell that delta x prime and delta t prime will be different. But that what they have telling here, they have told that the events can be simultaneous, but it will not be simultaneous at any position, because unless v is 0 it will not be simultaneous. So this condition will not be correct. That is fine that it is a function of v, but obviously delta t will be 0 even only if and only if v will be 0. If v will be 0, that means it is not moving at all, right? So this condition will not be considered here. Now coming to the fourth option, the events will be seen as happening at two different positions. We have already proved that x2 prime is not equal to x1 prime. That means it is not in the same position, it is at a different position. That means from that first question we can conclude that A and D option will be the correct one. A1 and T1 will be the correct one, because B and C will not be the case in this condition, whatever it is mentioned in that first question. Okay, so I think all of you understand the question clearly, so we will go to the next question, or if you have any doubt you can ask me. Okay, so coming to the next question. In the given reference frame, energy of a photon in a beam is 66 MeV. Taking the direction of the beam as z-axis, its force momentum with all number in MeV units is what? So force momentum, they are asking about the force momentum. So what will be the force momentum expression? Let's say I am writing here force momentum. Force momentum, how we can write? It is, let's say it is p mu. So p mu, how we can write it? It is E by C and P vector. Right, so E by C means, like, if it is in a natural unit, then C will be 1. So for the time being, or I think here it is, no, here they are not considering C equals to 1, so we are taking C as it is. Okay, so E by C, then Px is P vector is what? Px, Py, Pz. Right, so these things will be there as a force momentum vector. Now what they are asking in that question, the energy of the photon in a beam is 66 MeV. that means E will be 66 MeV, right? So energy of a momentum, energy of a photon beam is 66 MeV. Okay, so P0 is E by C, which is nothing but 66 by C MeV. Taking the direction of the beam as Z axis. So they have already mentioned that whatever the beam is there, it will go on the direction of Z only. So there will be no momentum along X and Y axis. So Px, Py will be 0. And what will be the Pz value? Pz will be exactly E, because we don't have any other component along X and Y axis. So that means whatever is the E, that is the Pz. So what will be the Pz here? Pz will be 66 MeV. Now if I write here 4 momentum of that 4 momentum, then what will be it? It will be like this one. So 66 by C. Now Px, Py, Pz. So you can see here Px is 0, Py is 0, and Px. Pz is what? As it is going along only Z direction, then it will be like 66 by C. Sorry, not C here. So 66. Now you can see here. Oh, sorry, it is P by C. So yeah. So 66 by C, 66 by C. So this is the correct answer. What is D? How it is coming? Just a minute. I'm coming. Okay, so let's come to the second question. Yeah, so in that second question you can see that P0 will be 66 by C, and as there will be no component along X and Y axis, so that means Px will be 0 and Py will also be 0. Okay, and the Pz value will be 66 by C. So the correct answer will be D. I hope it is understandable, or if you have any doubt you can ask me. Okay, we are moving to the next question. Yeah, this is the next question. What is the next question? Two particles A and B of the same mass 15 GeV each are collided to produce a heavier particle C of mass 200 GeV. What is the total energy of particle A in the center of mass frame needed for this? Okay, what is the total energy? Right. So what they have mentioned in that question, A and B are there, and if they are colliding each other, then it will produce a C. So what is the mass of each particle? The mass of each particle is two particles 15 GeV, 15 GeV. So this is 15 GeV, this is 15 GeV. And what they have produced? They have produced with the mass of 200 GeV, and the particle is named as C. So 15, these two will collide and it will make a heavier particle with mass 200 GeV. So at the very first, if I see that 15 GeV, how can it make the heavier particle like 200 GeV? So it can possible, because this is the rest mass. This is the rest mass of B and A. But we have the kinetic energy also. For each and every particle A and B, we have the kinetic energy. So the total energy, and obviously in any type of reaction, the total energy of left hand side should be equal to the total energy of right hand side. So the total energy of A plus total energy of B should be equal to total energy of C, right? Total energy of B, total energy B, total energy of C. That should be done in any reaction, not even a nuclear, then atomic or whatever. In any reaction energy should be conserved. So you can see here the total energy of A, total energy of B should be equal to total energy of C. As in the case of C is just now produced and there is no kinetic energy for that, it is only the rest mass energy, then we can write it as like 200 GeV only, right? And what about this one? Total energy of A means total energy of A, it can be written as, let's say, kinetic energy of A plus rest mass energy of A. So what is the rest mass energy? Rest mass energy is 15 because it is already given here. And what will be here the kinetic energy? Let's say it is X. Okay, so to have this kinetic energy A, kinetic energy B, it is like 200. As we can see that the rest mass of A and B are exactly same, that means 15 of each. That means we can roughly tell that. So it is like 100 and 100 is going as a whole 200, and if it is a 100 as a total energy of A, and also we know that the rest mass of A is 15, then we can definitely say what is the kinetic energy of A. The kinetic energy of A will be like 100 minus 15, which is 85. Okay, so that means let's say kinetic energy of A is 85. Now you can see how it is going to work. Kinetic energy of B 85, rest mass of A is 15, rest mass of B is 15. Then according to the energy conservation, total energy of A is kinetic energy of A plus rest mass of A, which is nothing but 85 plus 15, that is 100. Similarly, total energy of B is kinetic energy of B plus rest mass of B, which is 85 plus 15, nothing but 100. Now you can see the energy momentum conservation. The kinetic energy of A plus total energy of A plus total energy of B, what it is like 100 plus 100, which is 200, which is nothing but the total energy of C. And if it is a steady in a state, then total energy means there is no kinetic energy, only rest mass of C. And obviously in the question it is given that rest mass of C is 200. So according to the question, what will be the total energy of the particle in the center of mass frame needed for this? That will be 100 GeV, because kinetic energy is 85 and rest mass is 15. So as a whole, total energy of A is 85 plus 15, 100. So the right answer will be B. Okay. If there is a different mass, then we can have some different energy, different kinetic energy for A and B. But in that question they have simplified the question by taking that A and B mass are exactly same, each and every one has 15 GeV mass, and the heavier particle will have the mass 200 GeV. So that's why we can definitely say that the kinetic energy of A will be 85 and the rest mass of A is 15. So that's why the total energy of A will be 85 plus 15, which is 100. Okay. So I think that is also understandable. So we are going to the next question. So what is next question? Which of the following cannot represent the force momentum of a particle? The numbers are in appropriate units, and the number is like P mu is 7405, 10806, 7506, 10807. So to do that answer of the question, so what we have to know? The main thing we have to know here that we have from the Einstein special relativity expression, we can have an expression that E square should be P square C square plus M0 square C to the power 4, right? And E will be nothing but P square C square plus M0 square C to the power 4. That is the thing. So if you see that E square equals to P square C square plus M0 square C to the power 4, that means our M0 is obviously not negative value, right? So E will be greater than or equal to P. That is the main thing. E square will be greater than or equal to P square. Why equal to? When the equal to sign will come, if M0 is 0, let's say, then E square will be P square. In the natural unit, I am talking about natural unit. Let's say C equals to 1. In that natural unit, E square will be P square plus M0 square. So if let's say M0 is 0, then E square will be P square. M0 is greater than 0, then what will happen? E square is greater than P square. But in any situation that cannot be possible. M0 cannot be a negative number. This is a rest mass of that particle. So E square should not be less than P square. Okay. So this is the main outcome from our question, that E square should be greater than or equal to P square. Fine. Now coming to the question. So this should be for each and every condition. Okay. This should be satisfied for each and every condition. Now coming to the first option, 7405. It is showing that 7405. What is the meaning of this? I have already written that if P mu is there, that means this is E by C, Px, Py, Pz. Now we are talking about E square greater than equals to P square. Now let us check that E square greater than equals to P square will be satisfied in that value of P mu is or not. So let's say I am talking about C equals to 1. So that means E by C will be 7. That means E will be 7. So 7 square will be 49. And what about P square? P square is nothing but Px square plus Py square plus Pz square. So if I write here 4 square plus 0 square plus 5 square, then you can see P square will be 16 plus 0 and it is 25. So what will be the value? 1, 3, 4. So now previously it was like E square was 7 square, that means 49, which is obviously greater than 41, right? That means E square is greater than P square. So from the first option, what is A given in that, like 7, 4, 0, 5, in that combination we can have the condition that E square is greater than P square. So that means that this option will be correct. This expression can be a 4 momentum. But in that question they are asking about which one will not be the 4 momentum of the particle. So that means A will not be the answer. A is a 4 momentum, but they are asking about which one cannot be a 4 momentum. So now coming to the B, 10806. Similarly, we are going to write that square is 100 because it is 10 square. Now Px is 8, Py is 0, Pz is 6. Then what will be the value of Px square plus Py square plus Pz square? It will be 64 plus 0 plus 36. Now you can see, if I write here 60 plus 4 plus 36, it will be 100. That means our E square is 100, which is nothing but equal to P square. So I have already told you that condition that it can be possible that E square greater than equals to P square. So in that case you can see that E square is equal to P square. That means whatever the question option number B is there, 10, 8, 0, 6, that can be a 4 momentum. Okay. So that can, it is not that cannot be a 4 momentum. So the B option will not be the correct one for this question. Now coming to C, 7506. Similarly we have to check 7506. So what about 7506? E square is 7 square, 49. Px square, 5 square, 25. Py square, 0. Pz square, 6 square, 36. Now P square will be 25 plus 0 plus 36. Then what will be the answer here? The answer will be like 6. It is like 1, 5, 6. Now you can see that our E square was 49, but our P square is coming as 61. So that means E square is less than P square, which is not the condition for 4 momentum. So to be a 4 momentum as P, the E square should be greater than equals to P square. That condition should be satisfied. So the C option cannot be a 4 momentum. Okay. So the correct, and for this case the correct answer will be C. Now coming to D, 10, 8, 0, 7. I am just writing here simply 10, 8, 0, 7. You can see here E square will be 10 square, that is 100. P square will be 8 square plus 0 square plus 7 square. 64 plus 0 plus 49. It is obviously greater than 100. That means from the fourth option it is coming that E square is greater than, E square is less than P square from the D option. So that means it is not a 4 momentum vector. So the correct answer for this question will be C and D. So C and D cannot represent the 4 momentum of a particle. Okay, because to have the 4 momentum we have to consider this condition that E square will be greater than equal to P square. That is the condition. Okay, so this is the fourth question, I think. Yes. So till now if there is any question you can tell me, or otherwise I should move in the next question. Okay, maybe there is no question till now. So we can have the fifth question here. See, these questions are totally based on relativity, whatever sir told in his lecture. Okay. Okay, so coming to the fifth question. The question is okay. Yes. So the question is, two 4 vectors are P mu 8503 and K mu 6430. The value of P mu dot K mu is what? Write your answer as an integer. Okay. If, like they have already mentioned that write your answer as an integer means if there is any answer is coming like decimal something point something, then you have to cut that decimal point and you have to write it in integer form. But okay, fine, it's fine. So what it is given here, we have to write now 8503 8503, and what is K mu? K mu is 6430, and they are asking that P mu, K mu. Now you have to see a little bit more carefully that P mu, whatever it is given here, it is in contravariant form. This K mu is also in contravariant form. But when we are going to do the dot product of P mu and K mu, then one is in contravariant form and another one is covariant form. So we have to change K mu to K mu. That means K contravariant to K covariant. So how to do that? Sir already told in his lecture that let's say I am writing K mu. K mu will be what? G mu nu K nu. Okay, and you also know that mu and nu are dummy indices, then we can write like K mu can also be replaced as K nu also. So G mu nu, then K mu I am writing. K mu is what? 6430. 6430. And from his lecture also you can see that the G mu nu metric tensor has an expression which is nothing but G mu nu is 4 by 4 matrix 1 0 0 0 0 minus 1 0 0 0 0 minus 1 0 and 0 0 0 minus 1. So this is the metric tensor for G mu nu, G mu nu. Now let's say I was writing here K mu, G mu nu, K mu, right? So now what will be the value of K mu here? K mu will be nothing but whatever it is given here, 6430, 6430, but with a minus sign here. That means 6 minus 4 minus 3 minus 0. Obviously minus 0 and plus 0 has nothing, no meaning. So 6 minus 4 minus 3 0. That is K covariant mu. Okay. Now coming to the question again, they are asking about P mu, K mu. So what dot K mu? So what will be the answer for that? Let's say it is like P0, P1, P2, P3, and this is like K0, K1, K2, K3. And if it is a dot product, then what will be the answer? The answer will be like P0, K0 plus P1, K1 plus P2, K2 plus P3, K3. Okay. So now I am just going the expression for P mu again. The P mu was 8503. 8503. And K mu was what? K mu was like 6 minus 4 minus 3. Okay. So this is K mu. Then if I am going to calculate P mu dot K mu, then it will be like 8 into 6 plus 5 into minus 4 plus 0 into minus 3 plus 3 into 0. So what will be the answer? 48 minus 20 plus 0 plus 0. So 48 minus 20, it is 28. So there can be a possibility of that mistake, that when you are doing K mu dot P mu dot K mu, you are not consider that K mu as minus minus minus. Let's say if what will happen if I write wrongly, that means 8506 8506 or 3, whatever, 8503 643 6430. Let us know that I don't know about contravariant and covariant matrix and all. Then what will be the wrong answer? The wrong answer will be like, if we are going to do the dot product of this term, then it will be like 48 plus 20 plus 0 plus 0. Now you can see that previously it was 48 minus 20 and right now it is 48 plus 20. So mistakenly you can write the result as 68. but the result will not be 68. It is not correct. The result will be 28. It will be the correct one, because we have to change contravariant to covariant with the help of metric tension G mu nu, so that we can have a minus sign in in front of Px, Py and Pz, and according to that we are calculating the dot product of P mu dot K mu. Okay, so I thought that will be an important thing to know, so that's why 48 minus 20 will be 28. This is the case. So whatever the answer was, question was, the answer will be 28. Okay, so I think I should go to the next question. If you have any doubt, you can ask me anytime, no problem. Okay, yeah. So next question. The four-dimensional position coordinate of particle is x mu. X mu is t, x, y, z, and they are taking c is 1. That's why x mu is t, x, y, z. Otherwise, x mu will be like ct, x, y, z. Okay, and as in the natural unit they are taking c equals to 1, that means c mu will be t, x, y, z. Okay, fine. The four-dimensional position coordinate of a particle is x mu, it will be t, x, y, z, and its form momentum is p mu. P mu is 8404, where we have taken c equals to 1, and the values are given in appropriate units. The mass of the particle is what in appropriate units. So they are telling that x mu is this one. P mu is also given. P mu value is 8404. But they are asking what will be the value for m, that is the mass of that particle. So how to calculate that? From the Einstein's theory, then we know that E square is P square plus M square. I am not talking about C square, because in that question it is explicitly told that C is 1. So E square will be P square plus M square. So in the previous question also we told about what is E and what is P from that P mu. Let's say E will be what from here? E will be 8. And what will be Px? Px will be 4. Py will be 0. Pz will be 4. That is the thing. Right. Now coming to P square equals to P square plus M square. So E square is P square plus M square. Now what will be the P square here? Px square, Py square, Pz square. What is Px square? This is 404. That means 4 square plus 0 square plus 4 square, which is 16 plus 0 plus 16. That means 32. Okay. Now coming to E square. E square is what? E was 8. So E square will be 8 square. That means 64. Now from that expression, E square is P square plus M square. We all know the value of P square. We know the value of E square. Now from that we can definitely tell what will be the value of M square. Right? M square will be what? M square will be E square minus P square. Now just putting the values, what will be the expression? M square will be 8 square minus 32. 64 minus 32, that is 32. Now just see carefully, that was M square. M square is 32, but they are asking about M. So what will be M value? M will be root over 32. Okay. So from that expression, from that question I can have an answer that the four-dimensional position coordinate of a particle is x mu, t, x, y, z, and its pole momentum is p mu 8404, where we have taken c equals to 1 and the values are given in appropriate units. The mass of the particle is in appropriate units. The answer will be root over 32. That means that answer A will be the right one. We only need to know one expression, that E square will be T square plus M square. That is the actual expression for all the, for most of the questions of relativity. Okay. So let us go for the next question. This is the next question. The next question is the Kg equation, Klein-Gordon equation of a particle represented by the wave function psi is given by del 2 psi del t2 plus term 2 equals to minus 5 MeV psi. We have considered c equals to 1. In the term 2 is, the term 2 will be what? Okay. So basically the main thing is that we have to reproduce the Kg equation here, and we have to compare this Kg equation with that expression, nothing more than that. Okay, and whatever will be the term 2 we have to write here, then it is the term 2. Okay, now we are going to reproduce Kg equation. Kg equation means it is Klein-Gordon equation, right? So what is Klein-Gordon equation? See, I think sir has already told about the explicit expressions of Kg equations and all. So I am not going to do the detailed calculation of that one, but obviously very simple calculation, no problem. But still I am not going to do that detailed calculation. I am just going to tell one thing, that Kg equation is a very much similar to Schrodinger equation. Okay, so in the Schrodinger equation was what? H psi was E psi, that we all know, right? Hamiltonian is equal to the energy. So H psi is E psi. So H psi, in H psi what is there? H psi, in H psi it is like E. E, how can I write here? I H bar del T. Now coming to P. P is what? Minus I H bar grad. So also we know that T square plus C, sorry. M square. I am talking about all the things with the condition that C equals to 1. Okay. Now if I calculate the simple thing, like E square will be this one and T square plus M square. So as E is I H bar del T and P is minus I H bar grad, then what will be E square here? The E square will be I H bar del T whole square, that will be equal to minus I H bar grad square plus M square, right? So what will be here? It is like I square equal to minus 1, that means H bar square del 2 del T2 equals to, it is like minus H bar square, okay, del square plus M square. So if I write here, let's say del 2 del T2 plus del square, it was minus, right? Because like, okay, let me write here. This is equal. Now what I will do, I will just cancel minus from each and both sides, then it will be like this thing, E square del square minus M square, right? Now H bar square del 2 del T2 minus H bar square del square plus M square equals to 0. Why it is like that? It is psi also there, right? I forget to put the psi here. So there will be whole side, because E psi equals to H psi, right? So now what I can find that I find that expression, that h bar square del 2 del t2 minus h bar square del square plus m square as a whole psi equals to 0. And in that natural unit also h bar is 1 in natural unit. So the final result Kg equation will be del 2 del t2 minus del square plus m square psi is 0. Now we have to compare this expression from that whatever it is given in the question. Let us write here like that, del 2 psi del t2 minus del square psi plus m square psi is 0. So del 2 psi del t2 minus del square psi equals to minus m square psi. Now you can see from that question, del 2 psi del t2 is there. What I was written there, del 2 psi del t2 minus del square psi was minus m square psi. Then you can see del 2 psi del t2 is there, and from the right hand side minus 5 mV psi, that means minus m square psi is also there. So what will be the term 2? Term 2 will be nothing but minus del square psi. Now what will be the del square here? Minus obviously del dot grad psi. So the correct answer will be B. Here also if I write correctly, then it will be like del 2 psi del t2 minus this equals to this, and by taking the same value whatever is that question given, it is like so we can have the term 2 as minus this. Okay, so the answer will be B. Okay, so I think it's also understandable by each of everyone. So we will go to the next question. Yes, this is the next question. So given that E is minus grad phi minus derivative, E prime is minus grad phi prime minus del A prime del T. For E equals to E prime, which of the following is or are correct? Here lambda is a scalar function and c is the speed of light in vacuum. But sarcastically there is no lambda, there is no c present here in that expression, but it is fine, no problem. So there is a 4 options given. Either A prime is this, phi prime is this, A prime is this, phi prime is this, or A prime is this, phi prime is this, or A prime is this, phi prime is this. So there are 4 options. Now which one will be which one, or which are the correct one? To have the condition, you can see that the condition is like E should be E prime, that is the main condition, and E is that expression and E prime is that expression. So let us first write the expressions whatever it is written here. This and this. Okay. So now, okay. So what we will do, at the very first, I will check each and every option so that you can understand clearly which one will be the correct one. So A prime is what? I am talking about A. Question number A plus, I think that one, right? Yes. And 5 prime is 5 minus. 5 prime is 5 minus 10 lambda 10. Now, from that expression, what we have to do basically, here A prime and 5 prime is there. So that means we have to do only grad 5 prime and del A prime del T. So, this and 5 prime is 5 minus 10 lambda del T. Yes. So, this grad 5 prime del A prime del T. Now what will be the del A prime del T value? Then it will be del A del T plus del T of grad lambda. So as it can interchange, then we can write like that also. Okay, now coming to grad 5 prime. Grad 5 prime will be what? Grad 5 this. So if I write here correctly, then it will be like grad 5 minus grad of del lambda del T. Now you can see what was our E prime. E prime was 5 prime minus del A prime del T. So if I put these values, this minus del A prime. Del A prime is del A del T, del A del T. Okay. Okay. So plus minus plus. Okay. Plus right. So what will be the answer here? The answer will be like, now you can see here that there is minus grad of del delta del T, and also here in that minus grad del delta del T. So that means it is like minus 2 grad del delta del T. But in that expression of E, what was E here? E was like previously grad 5 minus del A del T. So that will not be the correct one, that E prime is E. So whatever is option number A, that is not exactly correct one. Okay. Now I'm jumping to the option D. Why? Because you all will understand why we are talking. Okay. This is minus, na? So I did a mistake. You people did not tell me. That is a minus, right? Minus, and then there will be minus. Okay, right. See. This is minus grad 5 prime minus A prime. So if it is minus grad 5 prime, then it will be minus, and then minus plus will be there, and then it is prime, right? Then what will be the answer here? Minus here, and then there is a minus, then it is like plus this minus this. Now you can see so from this you can see E prime will be minus delta minus del A del T, because there is a plus sign, there is a minus sign, so this will cancel out. So it is nothing but E. So E prime will be E. From that option number A. So whatever the option number A is there, that will give the correct answer, that E will be E prime. Actually previously I missed that minus here, so that's why it was not correct. Okay, now coming to B option. B option is what? The same for A prime but different from 5 prime. 5 prime is 5 minus divergence of A. phi prime is phi minus divergence of A. So phi means grad phi prime, grad phi minus grad of divergence of A. So you know what is grad of divergence of A, that is del square A. Okay, now you can see that I am going to write the E prime here. E prime will be minus phi prime minus del A prime del T. So minus means it will be phi plus del square A minus del A del T plus grad of del lambda del T. How it is coming? It has already there in the previous expression that A prime was A plus grad lambda. So that's why I just directly written that one. So yeah. So now you can see that minus grad phi minus del A del T, that much is E, no problem. But del square A is there and del of del lambda del T is there. So these two are not, these two are not cancelling. That means the main conclusion is like E prime is not E. Okay, so from that option number B, E prime is not E. Now, yeah, so we were talking about C option now. The first two options I had done. So right now we will talk about the C option. So we are talking about this option. So what is this one? This one is like A prime is A minus grad lambda, phi prime is phi plus del lambda del T. Now del A prime del T, then what will be the answer? Del A del T minus grad of del lambda del T. Similarly, now write quickly grad phi prime. Grad phi prime will be what? Grad phi plus grad of del lambda del T. Now we have to write the E prime. E prime is what? Minus del phi prime minus del A prime del T. Now if I just put all the values here, then it is like phi minus del lambda del T minus del A del T minus del lambda del T. Because you can see here that in that A prime it is minus, so that means it is minus coming. So if I write here minus del phi minus del with lambda del T minus del A del T, this minus and this is coming as plus del lambda del T. So what will be the answer here? The answer will be like this one. So which is nothing but E. So that means from that expression we can conclude that E prime is E. So we have already calculated the first one, that A was the correct one. E prime is going as E. And for C also we can say that E prime is going as E. Now coming to D1. D1 is what? Plus plus. Both are plus. Okay. You can obviously see that one, that it will not be the correct one, but it's fine. Lambda and phi prime is phi plus del lambda del T, I think. Del lambda del T. So yeah. So quickly we will do that one. Del A prime del T, then it is del A del T plus a grad of del lambda del T. Similarly, grad of phi prime is grad of phi plus grad of del lambda del t. Now what will happen, we will just write here e prime is minus this, then you can see minus this one del a del t minus del lambda del t. So from this you can conclude that it is like this minus del a del t, but here it is minus 2 into grad del lambda del t. So up to this it is e, but this is the extra part which is non-zero. That means we can conclude e prime is not equal to e from option number D. So what will be the correct answer here? The correct answer will be A and C. Now I can tell you one thing, interesting thing, that you can see that from that A and C option, A option is like something plus minus. That means A prime has plus, phi prime has minus. I am talking about this one. There is plus, there is minus. Similarly in C you can see there is minus, there is plus. So that means if it is like alternative sign is there for A and phi, at that time only we can have the option E prime is equal to E. But you can see here the same expression is there, but there is two exact sign, plus plus. So obviously you can also ask me that, let's say I am writing like that. Will it be the condition that E prime is E? Obviously not, because here is also minus minus. So whenever we will see that plus minus plus combination will be there, then only we can have a possibility that okay, E prime will be E. And also you can ask me that this, in that also there is E plus E minus is there, but the main problem is you can see that the expression is totally different. So here the expression is A plus delta lambda, that is grad lambda, that is fine, but for phi prime it is like phi minus divergence of A. There is no function as lambda, but for other options phi is a function of lambda. So that's why we can't get E prime equals to E from that B option. Okay, so I am going to erase these things. Yeah. So these things are there. So that means A and C will be the correct answer. Okay, so I hope it is understandable. Now we will go to the last question. So given that E vector is minus grad phi minus del A del t, E prime is minus grad phi prime minus del A prime del t. A prime is A plus grad delta. Phi prime is phi minus del lambda del t. Then which of the following is or are correct? Here lambda is a scalar function and c is the speed of light in vacuum. I have just right now told you that if let's say A is a function of lambda, phi is also a function of lambda with a different sign, that means plus and minus, then there is a possibility that E prime can be equal to E. But we have to check. Okay, here you can see there are four options. E prime is E, E prime is minus E, E prime is minus CB, and E prime is CB. Okay, so we have to check which one is the correct. So how B will come? If there is a curl of A like thing, then only B will come. Okay, so now come to the answer. Here you can see the E is like this one, right, and E prime is this. So now A prime is A plus grad lambda, phi prime is phi minus del lambda del t. So what we will have to do, we will like do this one. Fine. Now grad phi prime, grad phi, here is minus, right? So minus grad of del lambda del t. Now write down E prime here again. So we can write from here this plus minus del t, and here it is minus, and it was plus, so that means there will be a minus. So now from that expressions you can see minus this minus del A del t, which is nothing but E. So from that condition E prime can be as E, as I told you, right? So the option will be first one, E prime is E, and there will be only one option because E is correct, because obviously if E prime is E, E prime cannot be minus E, right? And E prime is also not minus CB, and E prime is also not CB. So as a whole the correct answer will be E, option E. So now you can see that we have done all the questions of previous year assignment, and there were 9 questions, so that's why we talked about 9 questions. So I am going through from the very first, if someone missed that. Okay, so as the connection was gone, that's why there is no answer right now, only the questions are here. But fine, I already explained the answers, so if you have some doubt you can ask me. So this is the first question, you can see. Now the second question is this one. And the third question is this one. Fourth question, this. Fifth question, this. Sixth question is this one. Seventh question is this one. Eighth question is this one. Ninth question is this one. So these questions were the previous year assignment question. So if you have any doubt, then you can ask me. Or if there is nothing, then we can talk in next class.
And can we discuss some other questions?
Some? I can't hear you properly. Can you tell me again? Hello?
Yes, it is. Can we discuss some other question
Which portion? This
for
one.
nuclear theory? No, no.
Can anyone tell, or can you please write it in chat box? I can't hear you properly. Who is talking? So can we discuss or what? After that I can't hear. Sorry. Okay, fine.
Ma'am, can we discuss first, second, and third?
First, second, and third question.
Yeah.
Okay. Okay. So, okay. So first question. First question is about relativity. Okay, special theory of relativity. So what is the question here? The two firecrackers are fired from the ground at the same spot. The second one is fired 5 seconds after the first one. As seen from a high-speed train moving with constant velocity, what will be the conclusion from that high-speed train moving with constant velocity? What can we see? That is the main thing, right? So for that, we have to write one in the presence of relativistic effect, our expressions of x prime and t prime, y prime, z prime are little bit different, right? So x prime means, let's say, x, y, z, t. These terms are in one frame, and in another frame the x prime, y prime, z prime, t prime. Okay, so it was already very much clearly discussed in Sar's lecture, so I am not going to write the explicit derivation of that. So I am just going to write here only the expressions. Oh, sorry, this will be only y, this is z, and this is t minus vy c square into x into gamma. Okay, so these are the expressions. Now let's say they are asking about two events. So let's say in first frame of reference there are two events at x1 t1 and x2 t2. In the second frame of reference the same thing will be like x1 prime, t1 prime, x2 prime, t2 prime. Okay, so these two will be there. Now as I told you that what will be the value of x1 prime, t1 prime, x2 prime, t2 prime, what will be the values? Just you have to replace that one by x1 prime, like x1 prime is x minus v t1 into gamma, t1 prime is t1 minus v by c square into x1 into gamma. Similarly, x2 prime is x2 minus v t2 into gamma, t2 prime is t2 minus v by c square into x2 into gamma, right? Now what we will do? Okay, so here the first frame means the ground is the first frame. Two firecrackers are fired from the ground at the same spot. So in that first frame of reference at the same spot means x1 and x2 are exactly equal. So what will be the value of delta x here? Delta x will be 0. Okay. The second one is fired 5 seconds after the first one. That means t2 is t1 plus 5. So what is the meaning of that? The meaning of that is like delta t is 5. In the first frame I am talking, I mean in the ground station. Now the second frame means inside the train. So train is a second frame of reference. As seen from a high speed train moving with constant velocity, what will be the conclusion? So now from the first two condition I can have one conclusion that delta x will be 0 and delta t will be 5. So if I write here delta x prime will be x2 prime minus x1 prime, which is nothing but delta x minus v delta t into gamma. Similarly, delta t prime will be delta t minus v by c square delta x into gamma. Now from that question I got one condition that delta x is 0 because these two events were at the same place, but delta t was 5. Now we have to just put that in the expression delta x prime. Delta x prime means delta x minus v into delta t into gamma. That means it is minus 5v gamma, right? And another one is delta t prime. Delta t prime is delta t means 5 minus v by c square into 0. So it is like 5 gamma. So we can conclude that delta x prime is minus 5v gamma, which is not equal to 0. Also delta t prime is also not equal to 0, which is 5 gamma. Now coming to the options, whatever it is given, the two events cannot be simultaneous. Two events cannot be simultaneous means x2 prime is not equal to x1 prime. That means what? That means the delta x will not be 0. So from our calculation also we can see delta x prime is not equal to 0, right? That means the first option will be correct. Now the second option, the two events are always simultaneous. Simultaneous means delta t. Simultaneous means delta t will be 0. So simultaneous means at the same time. So t2 prime will not be t1 prime. That means delta t prime will be not equals to 0. From our expression also we can see that our delta t prime was not equals to 0. That means first option will be correct. Now coming to second option, the two events are always simultaneous. As these two are totally disagree with each other, then this option will not be correct directly, right? Now coming to the third option, the events can be simultaneous or separated by a time interval depending on the speed of the train. But we have already told that delta t prime will not be 0 unless v is 0. If v is 0, then we can say that delta t prime will be 0. If v is 0 means there is no speed of that train. So that is nothing in meaning. So this one will also be wrong. Now coming to the fourth one, the events will be seen as happening at two different positions. That means x2 prime will not be x1 prime. And from our calculation also we can see delta x is not equal to 0. That means x2 prime is not equal to x1 prime. So this fourth option will be the correct one. So the correct options are A and T. Do you got the first question? Yes?
Yes, ma'am.
Okay.
Yes, thank you.
Okay. Now coming to the second question. You told about first, second, third. Okay. So the second question. In a given reference frame, energy of a photon in a beam is 66 MeV. Taking the direction of the beam as z-axis, its force momentum will be what? So for that we have to write the force momentum expression. How to write force momentum expression? It is like P vector. So in the P vector also explicitly I can write this and Px, Py, Pz. Now in that question they are mentioning that the energy is 66 MeV. That means E is 66 MeV. So what will be P0? P0 is E by C. That is 66 by C MEV. Fine. Now coming to Px, Py, Pz. In that question, they have mentioned that the direction of the beam as z-axis only. That means there will be no component along x and y axis. So Px and Py will be 0. Fine. And Pz will be non-zero. If it is non-zero, then what will be the value of Pz? Obviously, as Px, Py is 0 and our photon is talking about, in that photon the mass is 0. So from that expression E square equals to P square plus M square, we can see E will be P, and in that P, Px and Py is 0, so that means E will be Pz only. That means what will be the value of Pz? Pz will be nothing but 66. 66 by C. So the answer will be like 66 by C, Px 0, Py 0, Pz is 66 by C. So the correct answer will be, correct option will be D. E by C, Px, Py, Pz. Okay. Okay, so coming to the third one. In that third question, two particles A and B of the same mass are collided to produce a heavier particle of mass 200 GeV. What is the total energy of particle A in the center of mass frame needed for this? And there are 4 options. So let me write here A, B, C. So A is coming like that, B is coming like that, and after colliding there will be C. And mass of that A and B is like 15 GeV, and the mass of C will be 200 GeV. Now, in any type of reaction, our energy should be conserved, okay, at any cost. So if energy is conserved, that means total energy of A plus total energy of B will be total energy of C, because in the before collision A and B were the particles, and after collision C is the particle. So that means total energy of A plus total energy of B should be equal to total energy of C. Now total energy of B means what? Total energy is nothing but rest mass energy plus kinetic energy of A plus similarly rest mass plus kinetic energy of B is rest mass plus kinetic energy of C. But here, as C is just formed and there is no kinetic energy of C, that means total energy is equal to rest mass energy. So that means it will be 200 only, and there will be no kinetic energy for C. So in the right hand side it is 200. Now you have to see just the rest mass of A is 15. The kinetic energy of A you don't know. Let's say it is X. Similarly, rest mass of B is 15. Kinetic energy of B also we don't know. Let us consider it as X. Why the same parameter we are taking? Because the mass of this A and B are exactly same. That's why we are taking as X. Now you can see 30 plus 2x is 200. Now from that we can definitely tell what will be the value of X. It is 120. 200 minus 30 is 170. X is 85. So kinetic energy of A is exactly equal to kinetic energy of B, which is 85. Now in that question they were asking that what is the total energy of A. How to write the total energy? Kinetic energy of A plus rest mass of A. So kinetic energy is 85 and rest mass is 15. So that means it is 100. So
100.
in the question they are asking that what is the total energy of the particle A in the center of mass frame needed for this, that will be 100 GeV, which is the correct answer is B. Okay.
Thank you, ma'am.
Okay, so someone was asking something, so please explain the standard model of particle physics. Can we discuss other questions about nuclear physics? Yeah, obviously. Okay, so you want to know about standard model of particle physics. Yeah, that is a good thing. Okay, so standard model of particle physics. Standard model of particle physics means like, okay, is there any space so that I can write? Yeah, there is so much space. Standard model, okay, this is SM, standard model of particle physics. So, standard model means there is a model, and till now we are taking this model as the appropriate one for explaining all the particles in our nature. Okay, so all the particles in our nature means whoever is present in our universe as a particle, all the particles should be explained by standard model. That is the main thing. Now in standard model, how many particles are there? First of all, we have to answer that question. Obviously, how many particles are present in the universe, that should be contained in standard model, right? Otherwise, how can I tell that standard model is the only one successful model which can explain all the properties of all the particles? So in our universe till now there are so many particles, more than 100 or something. Okay, we have found till now. So we have to explain all the particles on the light of standard model only. But there is among these 100 particle or more than 100 particle, there is a very similarity between these particles. What are the similarities? Like some particles are baryon in nature, some particles are lepton in nature. As a whole, these are the fermions. Some particles also scalar in nature. These type of things are there. Okay, so fermion, bosons are there. So we can group all the particles in some different species. Like fermions means these are spin half particle. Bosons means these are spin. Not fermions means all the fermions are spin half. Basically, the fermions means it will be spin half integer, and for bosons it will be integer spin. So like that. And also among that fermion we can divide that as baryon, lepton and all the things, and there will be some mediator also. So in the standard model we are consider four forces in nature. So in standard model, electro weak, weak, strong. Basically not electroweak, I can write here electromagnetic. So these three can be explained by standard model. These three forces can be explained by standard model, but not gravity. Gravity cannot be explained by standard model. Okay, but whatever, at the very first I told that who are the particles in the nature, these should be explained by standard model. So the particles can be, particles explained by standard model means particles nature, particles properties, particles mass, spin, all the things, particles interaction, particles decay, how they can decay, how they can produce, all the things we can explain by standard model only. Okay, so that's why we need also, there are some mediators are there. Let's say W plus, W minus, Z0, then gluons, then gravitino is also there, but till now gravitino is there or not we don't know, so that's why we are just separating gravity as a different one from standard model. Then there is photon. These are the particles of these forces. These are the mediator of these forces which are also present in standard model. So if you see the standard model table, there is a table it is present in everywhere in internet or somewhere. Then you can see there is a table. In that table we can see one column is for mediators, how many mediators are there. Mediators are nothing but these mediators will be useful for mediating some specific forces. Let's say for electromagnetic, photon is mediating. From weak, these three are mediating. For gluons, these three, for strong, this gluon is mediating, like that. So one column is for mediators and another column is for lepton, another column is for baryon, like that. Okay. And inside in the baryon also there is some, like meson is also there, hyperon, like meson, base, baryon, all the things are there. So let's say lepton. So according to standard model there are 6 types of leptons: E, mu, tau. Like 3 types of lepton it is, but E, mu, tau, then nu E, nu mu, nu tau. And they are antiparticles: E plus, mu plus, tau plus, nu E bar, nu mu bar, nu tau bar. These are there. Okay. Now similarly baryon. In baryon they are considering that these 6 particles are fundamental one. Similarly for baryon, quarks are the fundamental one. So for quarks, how many quarks are there? 6 quarks are there. U up, down, jump, top. I should write like that. Up, down, jump, strange, top, bottom. These 6 quarks are there. And obviously if these 6 quarks are there, then antiparticles will also be there: U bar, D bar, C bar, S bar, T bar, B bar. So these are the fundamental particles for baryons, and these are the fundamental particles for leptons. Baryon, meson and all these things are the fundamental particle is quark, and for lepton family the fundamental is lepton itself. There is no other inside fundamental particle of leptons. These are itself a fundamental particle. But for baryon and meson, the quarks are the fundamental particle. So if I know the nature, properties of quark and leptons only, then only we can have the idea about all the existing elementary particles till now. And these nature can be expressed by standard model only. So nature means what? Nature means spin, isospin, strangeness, charge, I3, third component of I3, how they can decay, how they can produce, all the things. If we know about these quarks and leptons, then we can know all the properties of all the existing particles till now, and these things can be explained by standard model. But there is some loophole also, but yeah, we can discuss that loophole in next class also. Loophole means like standard model cannot explain mass of neutrino. We know the neutrinos has mass, so but standard model, in standard model if you see the table, inside the table the mass of neutrino is 0. So this can be a drawback of standard model. But till now most successful theory for particle physics is standard model. So like as a layman word I told you that what is standard model. So particle physics. If you have any question on that, you can ask me specific question on standard model also. You can tell me like what is standard model means. There is a very vast thing, right? But what is basically these things? Like it can explain all the properties, how it can decay, how it can produce, what is the nature, what is the mass, what is the speed, all the things it can explain. That is the thing we can tell. Okay, like if it's any sense to your question, I will see it. Okay, yeah. So there are so many books on particle and Newton particle physics, and obviously there are so many books on Standard Model itself. So you can see that one, so that it will be very much helpful. Like Standard Model means like there is a very vast thing. We have to explain all the particles, right? So that means we have to think about each and every particle and how they are behaving. That is the main thing. So yeah. And obviously you can see the table so that it will be very much helpful for you. How many mediators are there, how many leptons are there, how many quarks are there, and then what are the Higgs field is there, Higgs is also a boson, and then like all the gravitino is also there, but we don't know about gravitino, so we are not talking about gravity in the Standard Model itself, but yeah, we can separate it right now. But rest of the things like electromagnetic, weak and strong, these three forces can be explained by Standard Model very well. But till now, that is the most successful theory in particle physics, that we can say. Okay. Up to numerical questions, can I share? I need to understand. Okay, sure. Okay, so if you want to share, then I have to stop sharing. Yeah, share. Two particles are specified in the table. No, okay. Which question you are talking? 23? I think yes. You are muted, so I can't hear your voice. Both. Okay, both means 23 and 24, right? Okay, I hope it is yes. So 23, two particles are specified in the table below. Both enter a region of uniform magnetic field in a direction perpendicular to the field direction. Alpha particle and deuteron, rest mass, kinetic energy. If both the particles then follow circular trajectories in the magnetic field, the ratio of their time periods for one revolution must be. Oh, that is not exactly for the particle physics question. Okay, that is a simple nuclear physics question. Okay, so see, like there is a uniform magnetic field. So uniform magnetic field means what? So QVR, right? Like mv square I mean force is what? Force is like Q into V cross B. Q into V cross B is there, which is coming from magnetic field. Q into V cross B. Now Q into V cross B will be mv square by R, and yeah, mv square by R. So from that V I can tell the what will be the time period. V can be written as like 2 pi R by T, and the time period will be, I mean you can write like that, like 2 pi R by T is V, right? And now mv square by R equals to QVB. Then the one V will cancel out, from that T you can find, right? So from that, and also we can have the expression in terms of mass as well as kinetic energy. Now you just put the mass of alpha particle and deuteron particle, and then you just divide that one to have the answer. Like let's say T1 and T2. So T1 expression you got, T2 expression we got in terms of rest mass and kinetic energy of alpha particle and deuteron. Then you are just doing the ratio T1 divided by T2. I think you understand, or no? Okay, I'm just, I mean QVB is the force, right? Okay, let me read the second one, and after that I will take. Natural potassium contains a radioactive component of K40 that has two decay modes. In the first decay mode, K40 undergoes a beta decay to the ground state of calcium 40. Okay, In the second mode, K40 undergoes an electron capture to the excited state of argon followed by a single gamma transition to the ground state of argon 40. The amount of radioactive K40 in a natural potassium atomic weight of 39.089 sample is known to be 0.0118%. It is also known that in the decay of calcium 40, for every 100 beta particles emitted, their number of gamma protons emitted is 12. If the number of beta particles emitted per second by 1 kg of natural potassium is 2.4 into 10 to the 4, the mean lifetime of K40 in years is what? Okay, that is also a radioactive question, right? That is also not a particle physics itself a question. Like these two are not basically the standard model question. The first one is from simple magnetic field, and in presence of magnetic field, what will be the trajectory of the particle, like that. It is a nuclear physics question. And the second one is for radioactive question. So I think you understand the first one, and now second one is like, okay, oh, that I think I have already explained that one in question, like exactly not that question I explained. In the radioactive class I explained similar question. Like you can see here, the atomic amount of radioactive is natural potassium is known to be at a percent. That means we have to do all the things with respect to only 1.18%, sorry, 0.0118%. And then it is also known that the decay of atom for every beta particles emitted, their number of photons is 12. Okay, so how can I tell right now, but I can do by little bit copy, and after that I can share with you. Like it's a very simple question. It's only a radioactive question. So in that radioactivity, one main expression is there, right? That is dN dt equals to n e to the power minus lambda t, right? So there also, like, and also one more thing was they are asking about mean lifetime. Mean lifetime means what? T half. T half is nothing but 0.69, ln2 divided by lambda. So by anyhow, if you want, if you have the value of lambda, then you can have the value of mean life, T half. So okay, so if you want to know exact calculation, I can do one thing. I'm just going to have the screenshot of this page, and after that I can share with you the exact calculation. Okay, so you can share your mail ID or something with me so that I can send the exact calculation to you by mail. Understand? Or otherwise you can also do by yourself also, that is also fine. Like
Ma'am, can I share this on your WhatsApp?
okay, fine, no problem. And yeah, the first one is also very simple. I think first one you can do by yourself, or should I do that one also? Like you can understand that magnetic field is there, and in principle, in presence of magnetic field, what will be the force, and then according to that force we have to calculate the t value, and t value means the time period. Then we are just going to do the ratio. Or otherwise, if you want, then you can just send me in WhatsApp, and I can tell you after doing all the calculations then what will be the value of this. Okay,
Yeah, okay, ma'am.
okay, fine. So I think there is nothing more than that, so we can meet in next class. Bye bye.